Hey everyone! Today we're going to talk about solving quadratics, and we're going to go into a little bit more on perfect square trinomials. Later we're going to use these to help us solve quadratics. As a refresher from our previous lesson, we're going to solve the quadratic equations. But because these have linear terms, and remember linear means the term that only has an exponent of 1, this is your linear term, while the term with the exponent of 2 is the quadratic term. Because these have linear terms and they are quadratics, we need to factor in order to solve. So I'm going to add my 12 to both sides to start this off. I've got 2n squared plus 14n plus 12 equals 0. I then take out that common factor of 2, leaving me with n squared plus 7n plus 6. Using my diamond on the inside of those parentheses on the trinomial, I can factor this. The number on the end goes on top, that's a 6, and the coefficient on the middle term, 7, that goes on the bottom of your diamond. So now I'm looking for two numbers that multiply to 6 and add to 7, and those numbers are 6 and 1. So we split up our 7n to get n squared plus 6n plus 1n. Instead of that 7n, we're just rewriting it, plus 6. Splitting this in half, I take out the GCF on the left, which is n, leaving me with n plus 6. And on the right, I take out a positive 1, leaving me with n plus 6. There's an n plus 6 in common, so I factor this out, and I'm left with n plus 1. Don't forget to bring your 2 down, stays on the front, and it's all equal to 0. Now we take every factor containing an n and set it equal to 0 to solve. So n plus 6 equals 0, or n plus 1 equals 0. From the first, we find that n may equal negative 6, or from the second, we find that n may equal negative 1. Go ahead and pause the video real quick and try the next one on your own. Your two answers here should be v is 5 or v is negative 1. On this next slide, we're going to talk about solving quadratics with no linear term. We addressed this in our previous lesson, but we're going to go ahead and recap real quick. First, we're going to isolate the squared term. Here it's the entire n minus 1 that's being squared, so I'm going to isolate that by subtracting 5 from both sides. So on the left, I have n minus 1 all squared, and on the right, I have that equaling 9. So now that squared term is isolated on the left. So then, I square root both sides. I'm doing this to get rid of that exponent on the n and free it from that exponent of 2. On the right, I square root the 9. Do not forget your plus or minus in front of the 9. So the radical and the exponent cancel each other out on the left, leaving me with just n minus 1. And on the right, the square root of 9 is 3, so I have positive or negative 3. From here, I continue solving for the variable. But before I can do so, I need to write two equations. First, I have n minus 1 equals positive 3, and second, I have n minus 1 equals negative 3. Now, I can go ahead and add 1 to both sides of each equation to find my two solutions. So adding 1, I find that n equals 4. And on the right, adding 1, I find that n will equal negative 2. So my two answers are n may equal positive 4 or negative 2. Be careful. It is not possible to have the square root of a negative number. So if you ever run across a situation where you have the square root with a negative underneath, for example, maybe the square root of negative 16, this cannot be done. So you will say there's no solution to these equations. Now in later classes, you're going to talk about there being imaginary solutions. But within the scope of this class, we're just going to go ahead and say there is no solution. So to the right, I'm going to isolate the squared term by adding 11 to both sides. This gives me x minus 3 all squared equals positive 4, and then I square root both sides to get rid of that exponent over the x. Don't forget that plus or minus in front of the 4. Square rooting cancels the radical with the exponent and leaves me with x minus 3. And the square root of 4 is 2, so I have positive or negative 2. Writing my two equations, I find x minus 3 equals 2, or x minus 3 equals negative 2, and now I solve each of these equations. So x may equal 5, or x may equal 1. Go ahead and pause the video and try the next two on your own. For the first, you should have x is 2 or x is negative 6. And for the second, you did end up with the square root of a negative number, so there is no real solution to this equation. Moving on, we're going to simplify each of the following. So remember, this is going to go back a few months to when we multiplied binomials together by FOILing. I'm going to go ahead and write this out as x plus 4 times another x plus 4. To simplify, we FOIL. So first terms multiplied together gives me x squared. Distributing the x to the positive 4, we've got plus 4x. Then I'm going to distribute this positive 4 to my x, giving me a positive 4x. Notice I have two of the exact same thing. And then I multiply 4 times 4, giving me plus 16. When I simplify, I have x squared plus 8x plus 16. Moving on to the second, I have x plus 7 times x plus 7. I'll go ahead and distribute my x to get x squared. I then have plus 7x. I'm going to distribute my positive 7 to get a positive 7x. And I'll distribute my 7 to my 7, and I'm going to write this as plus 7 squared. I then simplify x squared plus 14x plus 49. And last, x minus 5 times x minus 5. I'll start by distributing my x. I get x squared. X times negative 5 gives me minus 5x. Moving on to my negative 5 times x gives me minus 5x. And negative 5 times negative 5 gives me positive 5 squared. I then simplify, so I have x squared minus 10x plus 25. Now I'd like to take a moment and look at the relationship between these terms. The relationship is that the constant term, so this term on the end of each expression, is the square of half the coefficient of the middle term. So if I take 8 and divide it by 2, I get 4. If I take 4 and I square it, I get 16. In the middle, if I take 14 and divide it by 2, I get 7. If I take 7 and square it, I get 49. Last, if I take negative 10 and divide it by 2, I get negative 5. If I take negative 5 and square it, I get a positive 25. So again, that constant term, or this term that's added on to the end, is the square of 1/2 the coefficient of the linear term, or the term in the middle. Now we're going to go ahead and factor each of these completely. So to factor, I multiply the first coefficient, which is a 1, by the last term, which is 36. That gives me 36 on top of my diamond. On bottom, I have a negative 12. My two numbers are negative 6 and negative 6, so I split up my negative 12k with negative 6k minus 6k. I still have the k squared in front and the plus 36 behind. Split down the middle, I get k times k minus 6, and then I take out a negative 6, which leaves me with k minus 6. K minus 6's are repeated, so I factor those out. And my second parentheses will also be k minus 6. Notice these are exactly the same, so I can continue simplifying into k minus 6 all squared. On the right, I'm going to use my big X again, 81 on top, 18 on bottom. My two numbers are 9 and 9, so I'll go ahead and split up my 18x as positive 9x plus 9x. I still have the x squared in front and the plus 81 behind. Split down the middle, I've got x times x plus 9, and on the right I take out a positive 9, leaving me with x plus 9. I see x plus 9 repeated, so I factor that out. And what's left in my other parentheses is another x plus 9. So just as in the previous example, I can simplify this further by writing it as x plus 9 all squared. Note, the expressions factor into perfect squares. So this original expression that we had factored into a binomial squared. And again on the right, this original expression that we had factored into a perfect square. The reason for this is, in the original expression, so looking up here to the original, the constant term, that would be this 36, is half the coefficient of the linear term squared. So if I take this negative 12 and divide it in half, so negative 12 divided by 2, I get negative 6. If I square that, I get positive 36. Same thing to the right. If I take the coefficient of the linear term, 18, and divide it by 2, I get 9. Now if I square that 9, I get 81, the constant term. Because of this relationship, these will factor into perfect squares, as we saw down below. Now we're going to determine if each of the following are perfect square trinomials. So we're going to check that relationship. Is the constant term the square of half the coefficient of the linear term? So here I'm going to take my 16 and divide it in half. 16 divided by 2 gives me 8. When I square 8, do I get 63? No, I do not. 8 squared is 64, so this is not a perfect square trinomial. Down below to the left, if I take 12 and divide it in half, I get 6. If I take 6 and I square it, do I get 27? I do not. 6 squared is 36, not 27, so this is not a perfect square trinomial. Go ahead and check the remaining 5 on your own after pausing the video. This third one should be a yes. Down here to the left, this would be a no. To the right, we have a yes. Down to the left, we have a yes. And to the right, we have a yes. Here we're going to go ahead and fill in the blank, so each of these quadratics is a perfect square trinomial. So we're going to put the constant number here in this blank that has the relationship necessary for this to factor into a perfect square. What I'm going to do is take that linear coefficient and divide it by 2. Here I get 4. When I square 4, I get 16. So I'm going to put a positive 16 here in this blank. So if we were to factor this, we would end up with a perfect square. To the left, I divide 4 in half and get 2. I then take 2 and square it to get a positive 4, so I put a positive 4 in the blank. In the middle, I'm going to take negative 8 and divide it by 2. That gives me a negative 4. I take that whole negative 4 and square it. Negative 4 times negative 4 is positive 16, so I write that in the blank. To the right, I take positive 10 and divide it in half. That gives me positive 5. I take positive 5 and square it. 5 times 5 is positive 25, so I add that here in this blank. Go ahead and fill in the remaining 6 on your own. You should have positive 9, positive 81, positive 9, positive 16, positive 121, and lastly, positive 64. Thanks so much for watching. I hope you guys have an awesome rest of your day.